Good morning, everyone. Now I'm going to explain the optimization of impact properties of copper polylactic acid composite using response surface methodology for the FDM 3D printing. First, we start with the introduction section. The additive manufacturing technology is also called as 3D printing, also named as rapid prototyping technology. It is a layer-by-layer manufacturing technology by using the CAD model data. The CAD model data is initially created by using the design software like AutoCAD, ProE, SolidWorks, like other softwares. After that, the digital models are converted into exported into the machine, and the printing is ongoing. Uh, in this FDM process is mainly depending upon the material extrusion. In here, the raw material are in filament form. The filaments are melted by using the heat extruder, and the filament is printed on over the printing bed. Compared to that other process, this FDM process has a lot of advantages. Likewise, it is easy to access. Cost-wise, it's less compared to the other machines, and handling is very easy. Flexible processing abilities it have, and it is very lightweight and easy to take out to anywhere. These are the main advantages of the FD machine. In FD machine, they mainly using polymer matrix composite for this printing process. In now my cases, I am going to use copper with PLA composite. Here, some of literatures are already done. The main thermoplastic polymers are used in this FD process is ABS and PLA. The PLA relatively having low melting point, like 15 to 60 degrees Celsius, and have a better strength compared to that other thermoplastic materials. It have a ETS load of 15.5 to 72 megapascal load, and also compared to that ABS material, it is biocompatible one. And these are my main objective of my this paper. First, I'm going to prepare the filament like a composition of copper and PLA composite, and then by using a different pattern and also by different percentage of infill percentage with the copper with the PLA, I'm going to test the impact properties of this FDM process, and also optimize the technique of this copper PLA by using ANOVA RSM technology, and this is the methodology for this process. In this, initially, the PLA is blended with the copper by using copper metal filled that Gizmodox machine, and then later I'm using the FDM 3D printer Van Hovo duplicate i3 desktop 3D printer, and I'm going to use different parameters on here, and different infill patterns, mainly rectilinear, grid, concentric, octagon spiral, and also honeycomb. And the infill pattern also, so infill percentage of copper with the PLE is also varied. Uh, Less than 15 to 80 up to 80 percentage of percentage is I'm going to add this, and this is the main parameters which I'm going to use this machine. The layer height is 0.3 mm, the infill and the other layer thickness of 0.3 mm, and the outer perimeter is 2, the nozzle diameter is 0.4 mm, and the filament diameter is 1.75 mm, and the extruder temperature of 210 degrees 210, and the printing speed of 30 mm per second, and the printing temperature is 60 degrees. This is the main impact test, and in the impact test they mainly difference into two types. One is choppy and another is ISO test. And after the impact test, we have some result on the different infill pattern, also different infill percentage like 25 to 80, and in here is that the highest energy is observed in concentric infill pattern of 2.7 joules. In 25 percentage of copper is mixed with it PLA, and also the grid infill pattern has the lowest energy observed in the process, like 0.63 joule, and also the 0.41 joule in for 25 and 80 watt percentage on here. And also the rectilinear infill pattern receives the energy absorption value to 1.3 joule and 25 watt percentage. And also this is the impact strength of this process. In here the highest impact strength is 37.91 kilos per meter square at noted in 25 percentage of copper with that PLA, and 90.45 percentage with the 80 percentage. And the grid infill pattern has the lowest impact strength of 5.78 at 80 watt percentage. And also I am going to optimize this technology to improve the parameters of this process, so that I am going to use the Pareto effect RSM technique, and this is the Pareto chart of this, and this is another chart where we are using the data and optimize the process parameters. And this is the main equation for energy observation in the optimization technique. And this is the actual predictor record, predicted energy, and also the experimental energy comparison table. Here initially the percentage of copper with the PLA is on the first column, and second is the actual reading what we are getting and the testing, and the predicted reading from that optimization technique, and the error percentage also in the video. And the my conclusion of this product is really the highest energy is observed in the concentric infill pattern by using this optimization layer 2.7 joule at 25 percentage of copper with this PLA, and also 1.39 joules in 80 watt percentage, 80 percentage of copper with this PLA. And also the grid infill pattern is having the lowest energy in this process at 0.63, and also 0.41 at 25 and 80 percentage of copper in the PLA respectively. And this is the end of the conclusion, and thank you.